See this code structure? Almost every tutorial teaches it, but almost every real project eventually deletes it. Not because it's messy, but because it silently kills your velocity as your app grows. Let me show you why this breaks down and what works instead. So why does this structure break down? Not on day one, not when the app is small. It breaks down the moment the app starts growing and real features begin to pile up. Let's say I'm working on the orders page. First, I add order history, then searching and filtering, then order refunds, then admin actions. Suddenly, one area of the app, orders, owns too much and all tangled together. And the root cause is simple. The code is structured around database entities, not around features. And that's when every small change starts feeling risky and slow. So if structuring your code around your database entities causes this mess, what should you do instead? What you should do is organize your code around behavior. And there are a couple of good ways to do that. We'll start with the first one, which is called the workflow approach. With the workflow approach, we stop asking questions like, what entity does this feature belong to? And we start asking instead, what workflow is the user going through? A workflow is a complete user journey from start to finish. Let's take the same e-commerce example and look at it through the workflow approach. One workflow might be placing an order. The user browses products, then adds items to the cart, then checks out, pays for the order, and finally receives a confirmation. Now here's the key shift. Each step in that workflow becomes a logical component. So instead of organizing your code around users, orders, and products, we end up with something like this: browsing, cart, checkout, payment, notification. Notice something important here. None of these components care about the database structure. The database supports workflows, it doesn't define them. This approach gives you two big advantages. First, you can understand what the system does by just looking at the code structure. A structure with browsing, checkout, payment tells a clear story. A structure called users, orders, and products almost tells you nothing about what does the system support and what features does it include. Second, each component stays small, focused, and manageable. No single area of the system grows into a massive, fragile piece of the system, because every component has one clear responsibility within the system. But here's one thing to keep in mind. You won't get this perfect from day one. You start simple, and as the workflow grows, you stop, you pause, you analyze, and you adapt. For example, if a component gets too big, you can split it. You can reshape boundaries when responsibilities change. That iteration isn't a failure of the approach, it's the approach working. The workflow approach works great when the system is driven by user journeys. But not every system looks like that. Some applications have a different kind of complexity. They have many different actors, and each actor can perform a specific set of actions. In systems like that, organizing code around user journeys or workflows starts to feel like it's forced. What really matters is a different question. Who is doing what? That's where the actor-action approach steps in. Let's take the same e-commerce app, but this time look at it as a marketplace and not just a shop for one owner. In a marketplace, the complexity doesn't come from the workflows alone. It comes from having many different actors, each with very different responsibilities. For example, we might have customers, shop owners, category coordinators, and admins. In systems like this, workflows alone don't fully capture what's going on. What helps is organizing the code around who does what. With the actor-action approach, we start by identifying our actors. Then, for each actor, we define the actions they can perform. For example, a customer can browse products, place orders, track deliveries, and request refunds. Now look at the shop owner. A shop owner can manage products, view orders, and handle fulfillment. A category coordinator has a different focus. They review listings, approve changes, and enforce category rules. And admins operate at the system level. They manage users, permissions, and platform-wide settings. In the actor-action approach, each actor owns its actions, and each action becomes its own logical component. Now this might look like a lot of components, but that comes from the complexity of the system itself. Such a system isn't simple. This structure doesn't create complexity, it reflects it. And by organizing the code this way, you make the complexity understandable and manageable. So, to wrap this up, if your code structure looks like your database, it will feel clean and simple at first, but you will struggle later on. A better approach is to organize your code around behavior. Sometimes that behavior looks like workflows, and other times it looks like actors and their actions. The key is choosing the structure that matches the kind of complexity your system has. If you found this useful, I share insights like this regularly in my free email newsletter. It's where I go deeper into topics like real-world architecture trade-offs, code organization patterns that actually scale. It's 100% free, and you can unsubscribe at any time. If that sounds useful, the link is in the description below. Thanks for watching, and I'll see you in the next one.